Okay, yes, it works. Okay, yes. So I'm going to talk a little bit about OTP and how you're actually accessing it, using it, even when you don't know about it. Okay. So what I first want to start off with is that OTP behaviors are not Elixir behaviors. If you look in the Elixir documentation, they've got something called behaviors, and that's not exactly the same as OTP behaviors. Right? So you have to be very careful about this, not to get them mixed up. That's just where I'm going here for. So another thing I want to point out, again, I think a lot of Elixir people don't realize this. They haven't had the need to realize it. But Elixir is built on top of Erlang and OTP. Okay, you often don't see it, but it's all there, right? For example, when you're compiling your Elixir code, that will generate Erlang code, which will then be passed into the Erlang compiler. When you're calling modules from Elixir, a lot of them will call Erlang modules underneath, amongst other things, the OTP behaviors. At the bottom of all this is the beam, which runs Erlang. Okay, and so all the features you're getting in your Elixir languages come from Erlang and the beam. It's just been wrapped in a very nice way on top, and they're provided a very large number of different packages for doing stuff, right? But they're all built on top of this. This is just something you should be aware of what's going on in there. And as I said, most of the time, you don't have to know about it, but it's there. Right? So, OTP behaviors. A bit about the design patterns for them. And they're a formalization of a design pattern, or some design patterns. That's what they are, right? Doing things in a specific way, or handling in a specific way. And processes in the low-level processes, they all look pretty much the same, have the same structure and same way of working. I've got another diagram coming afterwards. You start the process. They initialize themselves, and they sit there waiting for messages, and when a message comes, they process that message and do stuff, and then go sit and wait for the next message. So they're sitting in this loop. And then they're either terminated, or they might crash, or they might just live forever, right? What happened now? How do I get rid of this thing? Now it went. Okay. Here's the next one anyway. So yeah. So even if processes do different things, they will follow this standard set of patterns for it. And there can be different patterns built on top of this for doing different things. Okay. So this is the basic structure of all the processes running in the system at the low level. Again, very often, you won't be creating the processes, you won't see this, but this is what's going on internally, right? You start the process. There's a spawn function for starting a process, and that typically you'll call an init function with some input arguments, and that init function will initialize everything that process needs to know about. And typically it'll return a state saying, here is the state I'm going to be working on, and we're going to be processing stuff using this state. Again, this is what's happening internally. This is basically doing all the processes running in your system have this format, right? Whatever they're doing internally. And they'll go into a loop. And it's be a recursive loop there, typically, and you'll go into receive, excuse me, and you will receive messages, and you will process these messages and do something, right? So in this very general case, we see one message called handle with a message, and we call an internal function called handle, which does all the processing based on this message or what it's supposed to do and what the system's supposed to do, etc., etc. And then when it's done, it'll return the updated state, and we call ourselves recursively with the updated state. Okay. So the process just sits in a loop doing this. These might be internal processes. This is how file server processes they work. They sit there and wait for requests. This is how when you run IEX, the shell process does. It sits there, gets input, processes the input, output stuff, and then sits and waits for the next one. The processes just sit in a loop like this. And eventually, they might be sent some form of stop message, and then they'll terminate and clean up the state, whatever that might be. Okay? So, yeah. So OTP behaviors they're built on top of this design pattern. And they typically have something like this. We have on the left, can I point something here? Oh, I can, yes, we'll do that. Yeah, so on the design side here, I've got a number of clients, and when they want to do something with this server, they'll be sending requests into the server. The server will be sitting in the loop processing these requests. So it has its state it's working on and doing things. It might be talking with other processes, of course, most likely it will be, asking it to do things as well. And then when it's done, it'll send a response back to the client saying, yeah, this worked, here's the value, or no, it didn't, or it was bad, or it was good, or whatever, right? But you have this basic structure of the server sitting there. Now I'm calling it a server, it can be lots of things. Sitting there, getting requests coming in, processing these requests, and then sending a reply back and sitting waiting for the next request. They'll just do one request at a time. And again, this is exactly the same, for example, what the IEX shell does. It sits there waiting for requests coming in which case things you've written, and it will process these and send them back. You might have opened a file. You'll have a file process sitting there waiting for read and write operations. We'll be doing read and write to the low-level file. Or it might be high-level stuff too. You might be processing, might be doing things in Phoenix or something like that. They'll have the same basic structure internally everywhere for it. Okay. So what OTP design patterns are, there's a split. We try and split things up into a generic part, which all the servers do, and the specific part which your use of that server needs. Okay. So generic things are like starting the server, just starting up the process. They all do that. Keeping track of the data, the state. Here we're on the generic side, we don't know what the state is, but we're keeping track of it and passing it around. We saw that in the loop. And sending a request to the server, that's also generic. You call some function which sends a request to it, and sending back the reply to the client. And receiving reserve applies in the client, that's all generic stuff, right? This all happens without actually knowing what the server is doing and what our requests are. The specific side, however, of course, is initializing the server state. That's very specific, of course. So when we start the server, we say we're going to initialize it, we call some function to do the very specific initialization. The data, the state being passed around, of course, is specific. The requests we process, we handle, they're, of course, very specific as well for what this server is doing. Different servers will do different things and have different requests. Same thing with sending the reply back and handling the requests and cleaning up afterwards when we're told to stop. So we might have a lot of state, and we want to, when we terminate, we want to clean up the state so we don't leave a lot of garbage running around in the system, or having connected to other things, we need to stop this. So we've got this split between the generic and the specific. And this means in OTP behaviors, we split the thing up into two separate blocks of code. So we've got the generic part here, the generic behavior module. This contains all the generic code for running that type of server. We'll show an example later for it. And then we provide, for the specifics, we provide a callback module, which does all the specific stuff. So when the server process gets a request coming in, it's going to call a specific callback module to do the work. And the server, the generic part has no idea what's going on. It just got this message and the callback for it. And the generic bit, that's provided by OTP. Again, it's exactly the same thing on a lot of the packages you're doing, right? You have things like Phoenix. Phoenix will do an awful lot of the processing and handling for it, but you're telling it what you want to do when specific things come in, right? But how it handles it, how it sets up the TCP connections, handles data, it just does it for you, right? That's in the generic part of it. Okay. So in OTP, there are 5 standard behaviors that come with a basic system. There's a generic server, which is a client-server process. There's a state machine, which implements a state machine with a lot of very nice features in it. Yes, you can implement a state machine using a generic server and keeping track of the state yourself, but the state machine gives you an awful lot of nice features for doing that. There's an event handler, which is not quite like a server, but it's not used that much today and not in the Elixir side as well. There are supervisors. They're the ones that are used to build fault-tolerant supervision trees. Okay? So this is something like we've got on the right-hand side. We have supervisor processes and they have children processes. And supervisors manage their children. They know of their children. So if a child dies, the supervisor will typically restart that child process. And this is a feature you use, for example, I need a server in the system. I have to be running for my system to do its work. I'll have a supervisor managing that. So if that server process dies, it restarts it. So there's always a server running. Right? The application, then we're going up one level, again above this. And applications, OTP applications, they're the standard way of packaging things. And they're used inside Elixir packages as well too. That's how you group things together. That's how you bunch all the code that's taking part in this application. You make a specific data structure containing all this code. It will have a few functions or behaviors for starting things up and stuff like this for it. Now this is whether you're doing OTP or not. That's the basic packaging for systems for it. You mightn't see it as there, but if you go in and look, you'll find it, right? If you go in and look at the ebin directory, if in the package, well, after you compile it, you'll see there's a .app file, and that's something telling the application manager how to do things here, what modules are included, etc., etc., etc. So these are part of the standard OTP behaviors. Now, they are mapped onto the Elixir side as well, too. So the application, on the Erlang side here with the application, there's a module, there's a behavior, this has an Elixir behavior, again called application, it's uppercase for it, which is a mapping from the Elixir syntax onto the Erlang syntax at top as well. It typically does things by for example, changing the order of arguments. Because Elixir has a nice way of doing arguments. Erlang process functions have another way, so we want to map these things, they map over. And the same thing with the supervisor, that can go to the supervisor and the dynamic supervisor, depending on what you want to do here. The gen server in the Erlang side, that goes to the gen server on the Elixir side. It does exactly the same thing. They're calling the same code at the back end, it's just providing a more typical Elixir interface into it, so it looks much right. The gen state-m, the state machine, that doesn't really have an Elixir side. There used to be one called gen state machine, but from what I understand, that's been deprecated now. It's still there, but it's deprecated. And the same thing with the event here as well too. There is a gen event, but that's deprecated as well too. And if you look at the Elixir documentation, it says just use the gen event module straight off. And the same thing with the state machine. There are also a number of extra behaviors that are part of the standard Elixir release. There's the task, the agent, and the gen stage. We will be looking a little bit at the agent. Okay. So we'll be looking at the gen server, because that's a very common one that's used for a lot of things. A lot of other behaviors are implemented on top of gen servers. We'll see an example of this in a second. So we have, for example, taking part in the gen server, there are a number of interface calls. These two for starting them, we're saying which module, arguments to pass in, options as well too, and there's a callback. So I provide a callback, an init callback in my behavior module, and when someone starts it by calling the start function, then the behavior process will be started up, and it will call the init callback I provide for doing all the initialization. Again, we've got this split between the generic and the specifics. If I do a call request to the server and send a request in, then when the server gets the call request, it's going to call the handle callback, which I provide for doing all the work for that call. So I will see the request I get in, I'll see from who I got it from actually, and I'll see the current state, and I'll do lots of work processing this request, doing whatever I might need to do with it. And I just return from this function, return a reply tuple like this, and the behavior will send the reply value back and to the call here, and I'll get this as return value from the call. Okay. There's a cast, which just sends the message off. It just sends the message into the server, that's handled, then the server will receive this and say, oh, here we come a cast, I will call the handle cast callback for processing that cast. That does not return a reply. Casts are like Erlang process casts. They're send and pray, right? I send it off, I hope it gets there, I hope it does something, I don't know. There are other interfaces as well, but we'll be looking at these. Okay. So, yeah, we're going to look at one example here. We're going to look at the agent behavior, because the Elixir agent behavior is built on top of a gen server. Let's see, is that readable? Yeah, that is. Oh, we'll leave it like this. Okay. So there are a number of functions these are some of the functions that occur in the agent behavior, defined in the agent behavior on the Elixir side. There's a start one for starting up. Agents, they have a state, they have a data, and that data is accessed by sending functions on it, sending funds to it. So when I initialize it, I send it a fun. This fun's evaluated in the behavior process, the agent process, which then saves its return value. I can do a cast. I send a fun into the agent, and that fun will be called with the local state and will generate a new state, which will be saved. I can do a call with a fun as well too, which just says I'll send that fun in. It will process that call on that behavior data, and it will send the reply back to me. I can do get and update, which both sends the reply back and updates the state for me, or an update here, which just updates the state here. We see in the calls here, the synchronous calls, these are synchronous all, there's a default timeout of 5 seconds, which means if I don't get my reply back in 5 seconds, I'm going to get an error on the client side. This is also standard server stuff. Right? The fun bit here is, this is all implemented on top of a gen server. So here, the code is split into two modules, agent and agent.server. And the agent module is the one you call. That just calls gen server functions for doing this, right? So if I do a start, I call gen server start. If I'm doing an update date here, do a call with pass in the tuple get update and the fun for it, so that and then it's processed in the callbacks, right? Okay. So this is how I talk with the agent by using these functions which do gen server's call. Again, these are all just very specific. Or generic, sorry. Here is the agent. The agent server, this is the module we provide all the callbacks in. And we see here with the use, almost done, that it's a gen server, and here we have the init callback, which is going to be called when we do start up. We have a handle call, which is going to be called when we get a call request coming in, and we do different things. So if we're doing get with a fun, we just call that fun and return the reply. We don't change it. If we do a handle call with get and update, we call that function, the fun we send over, and that's going to return the reply and the updated state, which we then return. And if you get something else, we went wrong, and we do a bad return here and die. And we've got a handle call for just doing calls. We just call that function, return the reply. And cast, that just updates it and leaves it there. So here we see the agent is written on top of a gen server, using all the gen server stuff to handle the generic things for it. And we plug all the specifics in through the callbacks we provide in this callback module. So the agent has no idea, the agent supervisor or the agent code, behavior code, has no idea what it's doing. It just knows it processes the state, it gets a function, calls that function, saves the state back in. That's it, right? There's another module, sys, we'll have to go through this one. This is a very nice little module. It's for looking at and working with OTP behaviors. Yeah, I see the time. So, for example, I can turn on tracing by default here. So every time something's done in this server, I'll see trace messages in the logger for it. I can get the state out of it as well too. I can ask, what's the state in your server? And I'll get this back. I can replace the state and update it as well too if I want to from the outside, right? So I've got ways of looking and controlling things from the outside. And I don't have, we'll leave this. Okay, this is just how the synchronous call is done from inside in the Erlang module to make a very safe synchronous call. We'll leave that, and that's basically as far as I'm going. Okay, right. Okay. Yes.